Look at this canyon. It reminds me of the Grand Canyon. You've got this little stream, you've got these steep canyon walls. How long do you suppose it would take for a stream this small to remove this much material and cut the canyon this deep? This rock has a history, just like I do and just like you do. It came from somewhere. A lot of these rocks have been dated to be 350,000 years old, up to 2 million. That's pretty old. But it might surprise you to know that all of the geological formations that we see here, the canyons, the layers, even the plants, are younger than I am. When I was born, there was nothing here but a vast forest, hundreds of feet below where we're standing right now. In fact, before 1980, most people had never even heard of Mount St. Helens. It was in that year, on May the 18th, that molten rock created a steam blast with a force of 20 million tons of TNT. Avalanche debris and other flows from the eruption laid down all of those layers rapidly, up to 600 feet thick. A couple years later, there was some more volcanic activity that created a mud flow that cut out this entire canyon. It also cut through deep bedrock, all in a couple days. Isn't it amazing what a little bit of information from the past can do to help change your view of the present and the present world around you? There are a lot of assumptions made by a lot of people about the history of the Earth around us. The question is, how do those assumptions affect how we view that history? But more importantly, how do they play into how we view science and the Bible? Did God create the world in a few days or billions of years? Is mankind descended from apes, or did God create us instantly in his image? Was there a global flood that destroyed the earth, or is that a myth? In other words, is Genesis history? When we think about the history of the earth, there are a lot of things we need to consider. But one of the most fascinating is the account of the flood. Was the whole earth covered with water? Genesis says the waters prevailed so mightily on the earth that all the high mountains under the whole heaven were covered. So if the flood was truly global, wouldn't there be a lot of evidence? I'd heard of a scientist who had spent over 40 years studying this question. When I spoke to him, he said he had a great place where we could see evidence for the global flood. Steve, I gotta admit, I've been here several times, but every time I come here, it is breathtaking.
Besides being at home, Grand Canyon is my favorite place on Earth.
Yeah. So, Steve, tell me, what do you see here?
When we look at Grand Canyon, we see the inside story to the ground beneath our feet. And we kind of have a layer cake here, don't we, of strata that have been eroded for our benefit to see the inside structure of the Earth. These same layers are also in Colorado. We're also in Illinois, also in Pennsylvania.
So when you say sedimentary strata, you're talking about the layers that we see?
Yes. So the lowest layers are formed first. Those are sediment grains that were mixed, separated, and flowed in here from different directions and accumulated one on top of another. And then, of course, naturally, they convert to rock.
So you're saying that the solid ground we're standing on right now, if we went back in its history, it'd be liquid?
Yes. So the ocean is doing some amazing things, and water of incredible power is depositing the layers we see in the canyon.
And are there fossils in all of those layers?
There are marine fossils through all the layers. But the standard explanation is there were 17 different advances and retreats of the ocean over the North American continent, and it was extended over hundreds of millions of years.
And what is the evidence that you see here that would say that doesn't seem to make sense?
The 4,000 feet of flat-lying strata in the canyon are flat, and relative to one another, we look in between the strata layers and we don't see the passage of time in between layers.
You mean erosion?
Erosion, especially, and channeling on any great scale is not visible. And then we look at the strata themselves, and they provide evidence of rapid, very rapid sedimentation. Just minutes or hours is all that's needed to make layers.
Well, tell me about the story of these layers. I mean, how did they get here?
In the 600th year of Noah's life, on the second month, the 17th day of the month, the same day were all the fountains of the great deep broken up and the windows of heaven were opened. My understanding is the ocean floor upheaval occurred. Some type of magma or earthquake propelled the oceans over the continent.
So that's why we get these marine fossils in these layers.
Yes, and we have 6 months the waters prevailed upon the earth, another 7 months or so for the water to subside. The 4,000 feet of strata probably represents the early and middle part of the global flood right here in Grand Canyon. We have other strata locally in this Grand Canyon region. That's called the Grand Staircase. We have about 10,000 feet, 2 miles thickness of strata on top of the Grand Canyon.
Higher than where we are.
Higher than where we are, and that represents the later stages of the flood and the retreat of the floodwater. This surface was beveled by retreat of floodwaters, and as the flood retreated into the newly formed ocean basins, then the continents probably uplifted, and the ark, of course, was landed in the high country in the Middle East.
Well, there's some people who say that that record is about a local flood.
I believe it's a global flood, and all the high hills, or the whole heaven, were covered, a universal statement. But that mountains have risen since then, and we shouldn't measure the depth of the floodwaters by the present mountains of the earth, which are largely created during the flood and after the flood.
Well, the fact that we have all of these layers would be unknown to us if we were standing on them, you know, somewhere else, but they're known to us because they've been cut out. How did that happen?
Well, it was the story that we all learned in grammar school. Okay, Colorado River, over tens of millions of years, cut the Grand Canyon. Most geologists have jettisoned that idea. It's hard to sustain a canyon like this for tens of millions of years. You can't imagine a canyon enduring that long with erosion.
Is that because
right
it would
here.
have eventually, the sides would have collapsed and broken down? Then how in the world do we get this all carved out?
Well, there are lots of theories, and personally, I like the idea of catastrophic erosion by drainage of lakes.
So after the flood, we have these large bodies of water, these lakes that are trapped.
There's evidence of the big lake in the Painted Desert, a place called Hopi Buttes, about 500 cubic miles of water in this huge lake.
And so the dam breaks, and all of that massive amount of water then is now pouring out and carving this.
Yes, and how long would it take to erode Grand Canyon? Maybe weeks, but not millions of years. Time is not a magic wand that solves all the geologic problems of the world. Jettison that way of thinking about millions of years and then start thinking about catastrophic process like you've seen at Mount St. Helens, and that'll help you understand Grand Canyon.
Everywhere we looked, Steve showed me evidence of the incredible power of moving water. It quickly laid down these enormous layers, then quickly eroded them away. Steve wanted to show me where the floodwaters first hit the continent, so he took me deeper into the canyon.
Stephen, you said you were going to bring me to the bottom. You weren't kidding, were you? We're at the bottom, aren't we?
So we're in this big side canyon to the main Grand Canyon, and we're looking at the granite basement rock, which is the core of the continent, if you will. And then we see the flat-lying strata on top of it. The boundary between the granite rock below and the Tapete sandstone above is this surface we call the Great Unconformity.
Why does it appear to be such a stark line? I mean, it's clear.
I think it's an erosional boundary of colossal scale. We're looking at something that shows the magnitude of flood flow over a surface.
And is it just here?
The Great Unconformity is continent-wide. I've seen it, I believe, in the Middle East. It's over in Europe. It's in Africa, and here it is under the North American continent.
So we've got this layer. How thick is this layer? What goes up from here?
Well, we have the Sauk mega sequence here, if you will, 1,000 feet of sandstone, shale, limestone that goes continent-wide. There are 4 other big sequence packages of strata that sit above it. Those are also very continuous like this. What we're seeing here is rather representative of the rest of the world.
It makes one really question the notion that this all happened because of a small local flood. We're talking about something enormous.
The power-moving water was beveling and pulverizing rock, depositing great thicknesses of layers and calling our minds to think about a global flood.
The conventional story is entirely different, though. It would say that there is a lot of time between each of these layers.
Some people have said that the great unconformity boundary here represents 500 million years.
You mean between the granite we see and that first layer of the sedimentary rock?
Yeah, they say that there may be 500 million years there, okay? And that's what their explanation of Earth history would ask them to consider. Yet when you come here and look at this, nearly a featureless plain. It's not exactly a plain, but it's a gently rolling surface. And would that be the product of billions of years? Or would that be the product of the power of water planing off a surface? Time is foreign to a good explanation here. And so we want to explain what we see. Everywhere we look, we see the power of water. And it's water on a colossal scale, and that's the story here in Grand Canyon. It's not a little water and a lot of time. It's a lot of water in a little time.
I love coming to natural history museums. For me, as a paleontologist, it's like the chance to go to a zoo. It's all the animals that used to live before the flood. It's like a chance to step back in time.
It is like a zoo, except they're not alive.
Right,
They're all dead.
and they don't smell, so that's pretty good. And the Natural History Museum isn't just about telling us what was there. It's also trying to give us a storyline, right? And we've got 2 possibilities. We've got these 2 paradigms between a naturalistic view and a biblical view. And all the natural history museums in the country, most of them around the world, all give you just one of those views, only giving you the naturalistic, old Earth view of the world. But these same data, this dinosaur, is able to be understood in an alternate paradigm. So when I'm thinking about these types of creatures, I'm thinking about a world that's right before the flood.
I mean, this is a real picture of a violent world.
Yeah. That's why God said, behold, the end of all flesh. It wasn't just mankind. Man and all of the animals over which we rule are judged at the time of the flood.
Well, Marcus, can you kind of give us an overall picture of the fossils and how all this stuff fits together?
Yeah, fossils tend to be found in distinct layers where there are very, very large numbers that have been destroyed, untold billions. And so every time we see a layer of rock that's this thick, we're thinking about an event that probably took minutes to make, not thousands of years, minutes for just this one package of rock, sometimes even seconds, where these pulses of water from the flood are moving over the continents, grabbing ecosystems or dragging marine ones up from deeper in the ocean, and pulling them onto land. And as one gets deposited and the waves come back, they start pulling and piling additional stuff on top of that. And it's a graveyard on top of a graveyard on top of a graveyard. It's the sort of thing that speaks to catastrophe, not the sort of thing where the fossil record is gradually accumulating bone by bone, shell by shell, little by little, over untold eons of time.
So you're saying that we have these marine fossils all over, even on mountains?
Yeah. You know, further back over in the museum, they've got sections with things like mosasaurs, these big swimming reptiles. Mosasaurs are globally distributed, and they're distributed on continents. So looking at these things, you're saying, what is it that has the power? What is it that has the capacity to take the marine world and throw it on top of the continents in such a violent and destructive manner? And the flood makes perfect sense for this.
When we were in the Grand Canyon, we saw that great unconformity.
Yeah.
And there were no fossils to speak of really below that. And then all of a sudden we start getting a lot. What does that say to you as a paleontologist?
Well, the great unconformity is telling me that there's some sort of massive erosion and shearing that's happening across the continent. And then once we start getting to those nice sedimentary rocks that have all the wonderful fossils in them, the pattern starts to emerge. The ecosystem that has the first animals in it shows up very suddenly. In conventional paleontology, they call this the Cambrian explosion. It's the first appearance of a wide diversity of different types of marine animals. All of a sudden, you have this complex and whole ecosystem that shows up basically out of nowhere. Now, that makes perfect sense from a creation and flood perspective because the flood is about destroying ecosystems. Whereas in an evolutionary view, these ecosystems are going to have to arise a little bit more gradually as organisms diversify and evolve and respond to one another in their environment. But that's not what you see. Instead, you see an explosion of life that is complex, whole. The ecosystem is integrated with one another. You can see where all the different organisms fit with respect to one another. And that's just the first time that that happens. Every time you move up in the geological column, in this fossil record, you start seeing snapshots of more and more ecosystems. You've got one ecosystem that's destroyed, and then you've got another one. It's got slightly different creatures, there's different interactions going on, and as the floodwaters move higher and higher, they're getting closer and closer to shore, destroying more and more organisms in the shoreline and eventually up onto land.
Yeah. So I think I see what you're saying here, and that is that the paradigm that we're all taught, that conventional paradigm, is trying to tell us that the fossil record is an evolutionary picture of life as it is developing, as opposed to the Genesis paradigm that's saying, no, all of that life, all the complexity of life already was there, and now we're looking at the graveyard of all that life.
Exactly.
If the dinosaurs had died suddenly in the flood, wouldn't it be obvious?
What we're dealing with here, this is in the Lance Formation. This is a Upper Cretaceous sedimentary deposit. And what we have here is what's called a bone bed. It's an accumulation of bones that's about 1 meter thick, a little less than 1 meter. And in this meter, we find the bones present as a graded bed with little bones at the top and bigger bones at the bottom. And you can see here, looks like Kirline is working on another vertebra here. This is a cervical vertebra of a duck-billed dinosaur. This is where the spinal cord goes, right there. When I look at these bones in the quarry, I often think of them as being inside the animal alive, and just imagine what it's like to be seeing these bones for the first time. So this is just full of bones, and it's not like we have to go looking for where the bones are. We just have to sit down and start digging.
What is mainly different about the sites that you're digging here as opposed to what we would say a general dinosaur dig somewhere?
Well, there are dinosaurs found all over the world, but this particular site is unique in that it's probably one of the largest collections of bones in the world. And there are the remains of I'd say between 5,000 and 10,000 animals, each 20 to 40 feet long in this deposit. These are big animals, and there are a lot of them.
Let's step back for just a second. Okay, so we had a duck-bill dinosaur roaming around the Earth, and all of a sudden it dies. Would it become a fossil?
Fossilization requires very special circumstances. Normally, we know, for example, if a coyote dies out in the desert, its body is soon gone. Yet these bones are all perfectly preserved. They have never been subjected to weather. They are just all there. Today it would be very difficult to imagine how you could do that.
To some extent, we would really say that to find a fossil is rare. Even though we have many, many fossils, in terms of things that die, it's rare if they become fossilized.
It is rare. It requires special circumstances, not the least of which is rapid burial. These animals had to die, and then their carcasses had to have time to rot. So we're talking days or weeks or months, during which time the bones and tissues were either eaten away or rotted away. And then the bones that remained were deposited instantaneously in this environment, because they're in a graded bed with big bones at the bottom and little bones at the top. And you can see that here. The big bones are all down at the bottom. And when they start digging up here, they start to find smaller bones. So that condition requires a sorting process that can only take place during a catastrophic emplacement.
So when we look at the dinosaur fossils, rather than looking at them from the standpoint of we have early dinosaurs, then middle dinosaurs, then later dinosaurs, You're looking at from the perspective that all those dinosaurs were in existence. They were all living, and then there was this huge catastrophe that brought them to an end.
The dinosaurs are already dinosaurs when they first appear. They look just like anyone would think a dinosaur looked. And this is an enigma for those who believe in the evolution of the dinosaurs.
But we hear a lot about transitional forms. What's the real story there?
Scientists have been able to lay out some forms they think are transitional. And some of them are very interesting, some even challenging. But they are the exceptions to the rule. The rule is there are no transitional fossils. And what we find in the fossil record, and contra to Darwin's hopes, this is the rule, is that a form exists in the fossil record, it basically stays unchanged, and it disappears from the fossil record without having been changed. That's got to mean something besides evolution, because we don't ever see changes from this form into this form in the rocks themselves. So it's coming from somewhere else. It's a paradigm that's being imposed on the data rather than the data providing the paradigm. So I think it's very easy for me to be a creationist just based on my understanding of the complexity of life forms. And when we look at the fossil record, we can see that complexity is all there from the beginning, and this begs the question of where did all this complexity come from? It's one thing to have faith. I have faith that God was the creator, but that's substantiated by what I see around me. To say I have faith that evolution produced this when I can't even see how it could have happened, that's blind faith.
That's a leap in the dark.
That's a leap in the dark.
When I was with Art, he told me about some recent discoveries of material inside dinosaur bones. So I traveled to a lab in Arizona to talk to a scientist who is doing some of that research himself.
This is a fragment of a Triceratops horn. When we pulled it out of the ground, it fragmented, and then, of course, we've had to continue to fragment it in order to do analysis of it. In 2012, the Creation Research Society sponsored Mark Armitage and I to go to the Hell Creek Formation in Montana, which is a very popular place for finding dinosaur bones, and we instead dug out a almost 4-foot-long Triceratops brow horn. Now, it's just in crumbled pieces now, so we can't really, put it together and show you a horn. But yeah, you have to recognize that pieces such as this, we have found tissue with cells.
Oh, that's amazing.
And potentially proteins such as collagen. It's so difficult to understand how you could have this material still in a dinosaur fossil that is supposed to be 65, 75, 80 million years of age, because tissue, cells, proteins break down. They're not concrete, they don't just exist for eons of time, they break down. And in fact, they tend to break down fairly quickly depending upon the conditions. And certainly in Hell Creek, the conditions would be warm up, cool down, warm up, cool down. And any biochemist can tell you that is the fastest way to destroy material. It's difficult enough to envision it surviving for 4,000 or 5,000 years, but 60 million years, 70 million years, see, that really becomes very difficult to make any kind of biochemical basis for how it could have survived.
Okay, so once you find a sample like this, what do you do next?
So what we do is we soak the fossil material in a solution called EDTA. And what you'll have after you dissolve the fossil is the tissue will be remaining because the EDTA won't dissolve the tissue. So then I'll bring this over to what we call a dissection microscope. This is, in essence, dissolved Triceratops horn magnified. And so you can see what it looks like, just kind of little pieces of rock.
Well, Kevin, what did you find then when you were looking at the sample and you actually found some tissue?
Okay, here's what we found. This is actually Triceratops tissue. It's stretchable, it's pliable, it's not an impression of the soft parts of the dinosaur. This is truly soft, it is squishy, it is stretchable, it is tissue.
That blows your mind, huh?
Absolutely. And if you look at them then at a closer magnification, What we see then, this is using scanning electron microscopy. You see the extreme detail of the cells. See, in that picture, and this picture, and particularly like look at this picture, we would not begin to expect to see such enormous and elaborate detail. I mean, these structures are incredibly small. You know, this is our 20 micron bar here. See how small these structures are, still intact. It would take very little to break those. So at best, you would expect that all that would have broken off and been long gone.
So that has to have shaken up the scientific community. What's been the response of all of this?
The initial response, when Dr. Schweitzer first published her work, which is what became very popularized in 2005, it generated a lot of response. And so initially, some of the reaction was rejection. Oh, it's contamination. You know, that's not really dinosaur. It's bacteria, because bacteria can look kind of strange sometimes. So you had a lot of proposals of what it could be. And to her credit, Dr. Schweitzer did more work. They began to find protein. You break open some of these cells. You look at the matrix these cells are attached to, and they're protein.
Okay, so once that is understood,
yes,
then what happens? Now this is shaking it up, I guess.
That becomes part of the controversy, because clearly you're now faced with how could you explain the survival of this, the pristine survival of this, not only for so long, but in very unpristine conditions. And so then the controversy has been, how do you explain it? And if you read some of the literature, there's almost like desperation because they recognized what the implications of this could be. Now, some people would claim, well, it means nothing because we know how old they are, and therefore it just means it survived somehow, big deal. But how do you know how old they are? Well, you used methods, supposed methods of dating. Well, this is a method of dating. The tissue itself can't be discounted as part of a method of dating. So why do you say that doesn't count, but this does count? Well, it's all the paradigm drives your conclusions.
Rob Carter is a marine biologist, so he took me scuba diving to get a glimpse of a world most people don't see. His specialty was coral, and he knew a lot about the incredible creatures that inhabit the reefs around St. Thomas.
Oh man, we got the sharks here. I mean, just look how they move. I mean, it's almost like effortlessly glide along. I wish I could swim like that.
Engineers wish we could make boats like that.
Yeah.
Submarines that could move as efficiently as a shark. We can't quite do it.
So from your perspective as a marine biologist, and I know that you've studied the whole area of genetics a lot.
Yes.
When people talk about evolution, what is it?
How do you define evolution? The word means change over time. But I believe in change over time, but I'm not an evolutionist. So how does one figure this out? Really, evolution is a belief that enough change over time, over enough time, can lead to the common ancestry of all species on Earth.
All right.
So that's the part I reject. Of course species change. I mean, look at these sharks here. We have several different species of sharks. When God created, he put into those organisms the ability to change, to adapt, to respond dynamically to the environment. But they're still sharks. And when we look at the fossil record, they're still sharks. You know, people have heard the phrase the missing link. And they usually think of between man and monkeys. No, there's missing links between almost every major group of animal and almost every other major group of animal and plant, even bacteria, throughout the entire fossil record, which indicates very strongly that these are actually different creations.
So we don't get one kind becoming another kind?
No. Evolutionary theory requires that small, random changes can explain everything we see. But it can't.
And why can't it?
Because life is so complex that small changes can't explain it. Just like you can't take a computer operating system and look at it and say, oh yeah, this is built up one digit at a time over any length of time. No, it took an intelligent person to sit down and put it together.
Well, I can guarantee you, as one who was in that world, that if anyone in the area of computer science were to say, if we just randomly change some things in this operating system, it'll get better. I mean, no one would agree with that.
No, we're not going to get the shark to evolve into a bird. That the number of changes and the types of changes are not something that you can do one change at a time.
It's clear that the world we live in is incredibly interdependent, from the smallest biological system to the largest ecosystem. There are complex mutual relationships everywhere. I realize that creation in 6 days makes the most sense from an engineering perspective. You need everything working together at the same time for everything to function properly. And that's exactly how Genesis says God created it. Rob also said God created animals with the ability to change and adapt to their environments. Is it possible this ability to change has been mistaken for evolution? As Todd Wood and I walked through the zoo, we saw incredible beauty and amazing design wherever we looked. I noticed the great diversity between some animals as well as the remarkable similarity of others.
As a biologist, what do you see when you see all of these creatures?
Yeah, when I look at this, look at these lions specifically, I'm seeing cats myself. And all the other cats they have here at the zoo, they all have this underlying catness to them that's really apparent. It's really apparent when they start playing, right? You're seeing them playing with some sort of ball or something, and
They're just like a cat.
They look like a cat. You know, scientists would put that into a family called Felidae. And I would understand the felids to be representatives of a single created kind. So the continuity, the similarity there is so significant that I'd say, yeah, these guys have all descended from a single pair of critters that was on the ark, and that eventually generated all the different sorts of cats that we have today.
So rather than just a random accident, it appears as if all of these different species are coming from a really elaborate design.
Oh, absolutely. And it's not just a design like God, you know, designed and created the lion. It's God created something that could make a lion. So it's more like, you know, a multi-tool or a Swiss Army knife where you got all these pieces that you can just pop out whenever you need them, but it's all just one thing.
So give me some other examples of created kinds.
Yeah, so you've got the grizzlies and the polar bear. Those are all members of the bear kind. You've got ducks, swans, and geese. The thing about the dog kind is really interesting. So you take just this wolf-like creature, and we can breed in only a few hundred years many different breeds.
Well, Todd, that's kind of fascinating now to think about what God was doing when he was bringing two of every kind. What do you think was going on there?
Oh, yeah. I mean, he doesn't have to bring every little variety onto the ark. So when you actually do the calculations, and okay, so we don't know exactly how many created kinds there were on the ark, but maybe a couple thousand, and they're small. Most animals are quite small, so you have room to spare, literally room to spare. And all of that diversity that we have today is built into those two of every kind.
Well, Todd, we're looking at the zebras, and they're all unique, and yet all of these creatures are just so much complexity and diversity. How does the standard story, the conventional paradigm, explain all of that?
Well, they would use evolution, right? So millions of years, random variations, all things that are alive now, that cactus, that zebra, the grass here, it's all related. We all go back to a common ancestor that lived billions of years ago. And through the process of mutation and genetic variation and natural selection, that's where we get the stuff that we have today.
So, natural selection, what is it? Does it have the kind of creative potential that we need for all of this?
Natural selection is basically all about killing off things that aren't fit for the environment. So if you're a finch in the Galapagos and you have a really tiny beak and the only food available to you is really big, hard seeds, you're gonna die. And that's exactly what we observe. And so we can watch over the generations as the beak size and finches change in the Galapagos. But they're still finches, they're still birds. The notion that natural selection can generate all of the diversity we see, that's not been demonstrated. What we find most often with natural selection is that natural selection does a lot of fine-tuning. So right over here, we've got these oryxes, right? Beautiful creatures and very, very pale colors. The wild range of the oryx is right on the southern end of the Sahara Desert. And so you can see, yeah, their coloration makes sense. If you get a really dark-colored one, that's going to be really easy for predators to find. And so they end up being these really beautiful light colors. And that's an example of where selection would take a variation and turn it into an adaptation.
And that brings us back to the notion that a really exquisite design in the beginning
I think so. Absolutely.
Has provided these creatures with the ability to survive and to change for their benefit.
Absolutely. So the ability to be able to change your coloration like that, to be able to fit an environment, that's got to be built into the system before it starts. Now, don't get me wrong. I mean, natural selection and random variation can do amazing things. I mean, it's pretty astonishing the kinds of changes that we can see, but we don't see one kind changing into another. All we see are variations that happen within a created kind. So there's a felid tree, which has all the cats on it. There's the canid tree, which has all the dogs on it. There's the ursid tree, which has all the bears on it. There's the equid tree with all the horses on it. Each individual created kind, then, has its own individual tree, so that you end up with something like an orchard or a forest.
As a scientist, it seems what you're saying is that the Genesis paradigm answers all of this data better.
Ultimately, I think it does, because it embraces both similarity and difference. Now, as we've already said, there's lots of questions that are still out there. But I'm pretty confident, given what our paradigm can explain, I'm very confident that those answers are going to be found.
After we left the zebras, we made our way to the gorillas. Todd wanted to talk about the question of human evolution.
Todd, we see it all the time, a new discovery, new skulls, new skeletons that supposedly solidify this whole link.
Yeah.
What do you see there?
Absolutely. Well, I got some right here in my bag.
Ooh, a skull.
So this guy is a Neanderthal, very, very low forehead. So we have really tall foreheads. The face, the mid-face has been pulled out. But at the same time, well, it looks very human. So that's Neanderthal. You want to hold that one for me?
Yeah.
Okay. We have others that are very different.
Oh, yeah.
Now, this one is Australopithecus africanus. So you can see really no forehead at all. It just slopes right back. Very, very small brain case. Muzzle sticks way out, so the face is sloped forward. What do you do with this stuff? I mean, there's many more that we could show, many more pictures, many more skulls, and you can see, looking at them together, they're really, there's a lot of difference there.
Yeah.
Well, here's the thing. So all that created kind stuff that we already talked about, I can show again and again and again with multiple studies that I can find a discontinuity between humans and non-humans. So this thing lands on the human side. This Neanderthal here, it's one of us. This thing is not. It is different. But this would be just another one of those varieties of living things that God made in the beginning and that survived the flood aboard the ark.
So when we look at Neanderthal man, we're looking at a human, but it's a human that, just like we find in dogs, we have a lot of variety of dogs.
We got a lot of variety of people. So even looking back here at the gorilla, we can see the obvious differences between us and him, not the least of which is that he's in there and we can go home when we're done.
And so those differences are really huge, aren't they?
Yeah, absolutely. The image of God entails this idea of being God's representative here on this earth. Part of that, then, is having dominion and having authority, spiritual quality that we have that we don't share with animals like that.
Doug took me to one of the best archaeological museums in the world to show me some of the unique artifacts that relate to Genesis.
Well, the events of the Bible are unfolded in the ancient Near East, so all of these lands are extremely important to understanding how and what took place in the biblical text.
So this picks up these events we've been looking at in Genesis, from creation and the flood, and now we're to the dispersion of mankind out of Noah and his family.
Exactly. And the dispersion would have taken place somewhere in this mountain range to the northwest of Mesopotamia. And what we see in the biblical text in the narrative is that a number of people have migrated down to southern Mesopotamia, the land of Shinar, and moved toward the process of urbanization, city living.
And that's the famous Tower of Babel.
Absolutely.
Do we know where that is?
There are about 7 or 8 Babels, cities of Babel, in the ancient area of Mesopotamia. And so one at a time, I've studied all of those areas and found only one that meets all the criteria of the famous site of the Tower of Babel, and that is the site of Eridu, which is in southeastern Mesopotamia. We have signs of the expansion to the north, to the south, to the east, to the west, all the way as far as Egypt.
And when you say evidence, that is the artifacts that we find in these archaeological digs?
Exactly. There's an enormous amount and very specific kinds of material culture that attest to this expansion of people that I'm connecting to the post-Babel dispersion. Here are the beveled rim bowls, these two, which is that Rimkin brick that we see up there, and those 2 spouted jars. All of these diagnostic forms of pottery and material culture, they're found throughout the Near East. The Bible describes an event that's not just the confusion of language, but it's the dispersing of people far from that city. And because we see language or the written expression of language just pop up out of nowhere, and then different languages being represented through cuneiform script or through hieroglyphic script or other means. So you do not have a universal plan that's followed among all of the languages. You see great diversity in the forms of grammar from language to language, even in ancient languages.
It seems then that the event recorded in Genesis about the Tower of Babel, that's a very, very critical event for archaeology.
It is. So all of this fits perfectly with what we would see as the biblical account of how languages took place. It's really the only way of explaining this. So the integrity of biblical history ultimately is justified by the expression of these languages.
Now, most of us think today of a tower, the kinds of things we see in big cities, big straight walls. Is that what they were building?
Well, essentially, it's a variation of a pyramid. And there were 4 sides to it and several stairways that would go up to the top. At Eridu, we have a temple that existed in 18 different phases. And at every phase, it grew in its size and its complexity. And that final temple, that final phase of the temple, it was abandoned immediately, right at the time of the late Uruk expansion. Catacorner to the temple was an absolutely enormous platform.
Do you think that could be the foundation of the Tower of Babel?
Absolutely, and I would suggest to you that this late Uruk expansion, where this technology began, was something that spread with the people. We find forms of these ziggurats all around the globe. We find them in China, we find them in India, we find them in various parts of the Americas. We find them all over.
Well, obviously we have evidence here of civilization and people beginning to gather together in communities, even cities. Do we have any other evidence of that?
Absolutely. We can move forward to the time of Abraham because we know that Abraham lived at the site of Ur, which was also in southern Mesopotamia, at the end of the 3rd millennium BC.
That brings us to the end of Genesis chapter 11.
Exactly. In fact, you see some pottery, some cuneiform tablets, all dating to the period of the 3rd dynasty of Ur.
It's amazing just as we're sitting here thinking about that, thinking about Abraham and that this represents the culture and the civilization that he lived in. It's a great tie to that record in Genesis 4.
It is fascinating, and it gives you a feeling of putting your hands around the events that go on in the biblical text.
When I look back through history, I realized each of these cultures had been impacted by the events recorded in Genesis. George Grant wanted to meet me at a garden near his home. He said it was a good reminder of where our history began.
So there's something significant about the Genesis text in which Adam and Eve are then placed into a garden to tend it. That's more than just a story.
It's much more than just a story. One of the things that you see in Genesis chapter 1 is the structure for time. The universe is created for a 24-hour day. And so everything from the way our sleep cycles and the way our work cycles work all come from that definitive historical account there. When we get to Genesis chapter 2, we start to see the meaning and purpose of man. Of course, in Genesis chapter 3, we see the disruption of everything by the fall. And the implications of an historical fall, an actual man and an actual woman who actually yielded to actual sin, have then implications all through the rest of the Bible. If you remove a literal Adam and Eve, that changes the whole shape of what history is and how history is remembered.
I think most Christians, when we talk about, for example, the life of Christ, those are understood to be historical accounts. Right. Why is it that when we look at the account in Genesis, that we have a tendency not to want to do that?